DISI survey validation data in the cosmos. HSC field cool gas trace main sequence star-forming galaxies at the cosmic noon. We present the first result in exploring the gaseous halo and galaxy correlation using the dark energy spectroscopic instrument survey validation data in the Cosmic Evolution Survey and Hypersoprine KF. We obtain the multiphase gaseous halo properties in the circumgalactic medium by using 115 quasar spectra. We detect MGI absorption at redshift 0.6 less than Z less than 2.5, SIV absorption at 1.6 less than Z less than 3.6, and H1 absorption associated with the MGI and SIV. The CGM is mixed by a higher density phase of detectable MGI and SIV and a lower density of SIV-only phase. By cross-matching the Cosmos 2020 catalog, we identify the MGI and SIV host galaxies at 0.9 less than Z less than 3.1 in 10 quasar fields. We find that within the impact parameter of 250 kpc, a tight correlation is seen between strong MGI equivalent width and the host galaxy star formation rate. The covering fraction Fc of strong MGI selected galaxies, which is the ratio of absorbing galaxy in a certain galaxy population, shows significant evolution in the main sequence galaxies and marginal evolution in all the galaxy populations within 250 kpc at 0.9 less than Z less than 2.2. The Fc increase in the main sequence galaxies likely suggests the co-evolution of strong MGI absorbing gas and the main sequence galaxies at the cosmic noon. Furthermore, several MGI and SIV absorbing gas is detected out of the galaxy virial radius, tentatively indicating the feedback produced by the star formation and/or the environmental effects. Next article. Astrometric apparent motion of high redshift radio sources. Radio-loud quasars at high redshift are rare objects in the universe and rarely observed with very long baseline interferometry. But some of them have flux density sufficiently high for monitoring of their apparent position. The instability of the astrometric positions could be linked to the astrophysical process in the jetted active galactic nuclei in the early universe. Regular observations of the high redshift quasars are used for estimating their apparent proper motion over several years. We have undertaken regular VLBI observations of several high redshift quasars at 2.3 GHz and 8.4 GHz with a network of 5 radio telescopes, 40 N-YEBs, 25 M Sheshan, and 332 M telescopes of the quasar VLBI networks Svetlo, Zelenchuksky, and Battery. Additional facilities joined this network occasionally. The sources have also been observed in 3 sessions with the European VLBI network in 2018-2019 and 1 long baseline array experiment in 2018. In addition, several experiments conducted with the Very Long Baseline Array in 2017-2018 were used to improve the time sampling and the statistics. Based on these 37 astrometric VLBI experiments between 2017 and 2021, we estimated the apparent proper motions of 4 quasars 0901 697 1428 422 1508 572 and 2101 600. Next article. 2-photon production in low-velocity shocks. The galactic interstellar medium abounds in low-velocity shocks with velocities less than, say, about 70 km/s. Some are descendants of higher velocity shocks, while others start off at low velocity. Low-velocity shocks cool primarily via light alpha, 2-photon continuum, optical recombination lines, free-bound emission, free emission, and forbidden lines of metals. The dark far ultraviolet sky, aided by the fact that the two-photon continuum peaks at 1,400 angstroms, makes the FUV band an ideal tracer of low-velocity shocks. Recent Galax FUV images reaffirm this expectation, discovering faint and large interstellar structure in old supernova remnants and thin arcs stretching across the sky. Interstellar bow shocks are expected from fast stars from the galactic disk passing through the numerous gas clouds in the local interstellar medium within 15 pc of the Sun. Using the best atomic data available to date, we present convenient fitting formulae for yields of Li alpha, 2-photon continuum, and H alpha for pure hydrogen plasma in the temperature range of 10 to the power 4K to 10 to the power 5K. The formulae presented here can be readily incorporated into time-dependent cooling models as well as collisional ionization equilibrium models. Next article. Jet-induced molecular gas excitation and turbulence in the teacup. In order to investigate the impact of radio jets on the interstellar medium of galaxies hosting active galactic nuclei, we present subarcsecond resolution Atacama large millimeter simillimeter array CO and CO observations of the teacup galaxy. This is a nearby radio-quiet Type II quasar with a compact radio jet that subtends a small angle from the molecular gas disk. Enhanced emission line widths perpendicular to the jet orientation have been reported for several nearby AG and for the ionized gas. For the molecular gas in the teacup, not only do we find this enhancement in the velocity dispersion but also a higher brightness temperature ratio perpendicular to the radio jet compared to the ratios found in the galaxy disk. Our results and the comparison with simulations suggest that the radio jet is compressing and accelerating the molecular gas and driving a lateral outflow that shows enhanced velocity dispersion and higher gas excitation. These results provide further evidence that the coupling between the jet and the ISM is relevant to a GN feedback even in the case of radio-quiet galaxies. Next article. Spiral galaxies. Our vision of galaxies has changed significantly since the era of large galaxy surveys like the Sloan, which gave us extensive statistics with millions of galaxies. The Hubble sequence classification described in Chapter 1 still remains very widely used but has been enriched with broad categories based on color that indicate the recent formation of stars. The RAN sequence of passive galaxies consisting solely of old stars, and the blue cloud of galaxies with active star formation. Chapter 3 focused on galaxies with a dominant spheroid, which are generally found on the red sequence. One of the key questions about the evolution of galaxies that remain to be answered is to understand how a galaxy can suddenly pass from one category to another. This is a graduate student level lecture, not a review article. Next article. Galactic bulge black hole co-evolution feeding and feedback of ANS. Since the 1990s, we have known that there is a supermassive black hole in every galaxy, and that its mass is proportional to the mass of the bulge. To better understand how these black holes were formed in symbiosis with their galaxies, we will look at their demography, the scaling relations between properties of black holes and host galaxies, and their evolution in a Hubble time. Observations at high annular resolution now allow us to enter the black hole sphere of influence, to see the molecular theory evoked in the AGN unification paradigm, and to understand the feeding processes of black holes. These are often accompanied by feedback processes, which moderate the formation of galaxies. This is a graduate student level lecture, not a review article. Next article. nuclear and electromagnetic cascades induced by ultra-high energy cosmic rays in radio galaxies. Implications for Centaurus A. Next article. New mechanisms for forming multiple hotspots in radio jets. Hotspots of radio galaxies are regions of shock-driven particle acceleration. Multiple hotspots have long been identified as potential indicators of jet movement or precession. Two frequent explanations describe a secondary hotspot as either the location of a prior jet termination point or a deflected backflow-driven shock, the so-called dentist S-drill and splatter spot models. We created high-resolution simulations of precessing jets with a range of parameters. In addition to the existing mechanisms, our results show three additional mechanisms for multiple hotspot formation: the splitting of a large terminal hotspots into passive and active components, jet stream splitting resulting in two active hotspots, dynamic multiple hotspot complexes that form as a result of jet termination in a turbulent cocoon linked here to rapid precession. We show that these distinct types of multiple hotspots are difficult to differentiate in synthetic radio maps, particularly hotspot complexes which can easily be mistaken for the jet itself. We discuss the implication for hypothesized binary supermassive black hole systems where jet precession is a key component of the morphology, and show a selection of potential precession candidates found using the LOFAR 2-meter sky survey data release 2. Next article. Phase space mixing of a Vlasov gas in the exterior of a Kerr black hole. We study the dynamics of a collisionless kinetic gas whose particles follow future-directed timeline and spatially bound geodesics in the exterior of a subextremal Kerr black hole spacetime. Based on the use of generalized action angle variables, we analyze the large-time asymptotic behavior of macroscopic observables associated with the gas. We show that, as long as the fundamental frequencies of the system satisfy a suitable non-degeneracy condition, these macroscopic observables converge in time to the corresponding observables determined from an average distribution function. In particular, this implies that the final state is characterized by a distribution function which is invariant with respect to the full symmetry group of the system, that is, it is stationary, axisymmetric, and Poisson commutes with the integral of motion associated with the Carter constant. As a corollary of our result, we demonstrate the validity of the Strong-Jeans theorem in our setting, stating that the distribution function belonging to a stationary state must be a function which is independent of the generalized angle variables. An analogous theorem in which the assumption of stationarity is replaced with the requirement of invariance with respect to the Carter flow is also proven. Finally, we prove that the aforementioned non-degeneracy condition holds. This is achieved by providing suitable asymptotic expansions for the energy and Carter constant in terms of action variables for orbits having sufficiently large radii, and by exploiting the analytic dependency of the fundamental frequencies on the integrals of motion. Next article. Approximate molecular quasar absorbers, chemical enrichment, and kinematics of the neutral gas. Approximate molecular quasar absorbers are an intriguing population of absorption systems recently uncovered through strong H2 absorption at small velocity separation from the background quasars. We performed a multi-wavelength spectroscopic follow-up of 13 such systems with VLTX shooter. Here, we present the observations and study the overall chemical enrichment measured from the high H2 and metal lines. We combine this with an investigation of the neutral gas kinematics with respect to the quasar host. We find gas phase metallicities in the range 2% to 40% of the solar value, i.e. in the upper half range of high selected proximate damped Lyman alpha systems, but similar to what is seen in intervening H2-bearing systems. This is likely driven by similar selection effects that play against the detection of most metal and molecular-rich systems in absorption. Differences are, however, seen in the abundance of dust and its depletion pattern when compared to intervening systems, possibly indicating different dust production or destruction close to the end. We also note the almost ubiquitous presence of a high ionization phase traced by NV in proximate systems. In spite of the hard UV field from the quasars, we found no strong overall deficit of neutral argon, at least when compared to intervening DLAS. This likely results from argon being mostly neutral in the H2 phase, which actually accounts for a large fraction of the total amount of metals. We measure the quasar systemic redshifts through emission lines from both ionized gas and CO emission, the latter being detected in all 6 cases for which we obtained 3 mm data from complementary NOMA observations. For the first time, we observe a trend between line-of-sight velocity with respect to systemic redshift and metallicity of the absorbing gas. Truncated. Next article. UV Li-alpha halos of Li-alpha emitters across environments at Z284. We present UV and Li-alpha radial surface brightness profiles of Li-alpha emitters at Z equal to 2.84 detected with the hypersuprime cam on the Subaru telescope. The depth of our data, together with the wide field coverage including a protocluster, enable us to study the dependence of Li-alpha halos on various galaxy properties, including MPC scale environments. UV and Li-alpha images of 3,490 Lis are extracted, and stacking the images yields SB sensitivity of 11020 arc S1 cm2 arcsec2 in Li-alpha, reaching the expected level of optically thick gas illuminated by the UV background at Z3. Fitting of the two-component exponential function gives the scale lengths of 1.56, 0.01, and 10.40.3 pkpc. Dividing the sample according to their photometric properties, we find that while the dependence of halo scale length on environment outside of the protocluster core is not clear, Lis in the central regions of protoclusters appear to have very large laws which could be caused by combined effects of source overlapping and diffuse Li-alpha emission from cool intergalactic gas permeating the forming protocluster core irradiated by active members. For the first time, we identify UV halos around bright Lis which are probably due to a few lower mass satellite galaxies. Through comparison with recent numerical simulations, we conclude that, while scattered Li-alpha photons from the host galaxies are dominant, star formation in satellites evidently contributes to loss, and that fluorescent Li-alpha emission may be boosted within protocluster cores at cosmic noon and or near bright QSOS. Next article. Anisotropic mass segregation two-component mean field model. Galactic nuclei, the densest stellar environments in the universe, exhibit a complex geometrical structure. The stars orbiting the central supermassive black hole follow a mass-segregated distribution both in the radial distance from the center and in the inclination angle of the orbital planes. The latter distribution may represent the equilibrium state of vector-resonant relaxation. In this paper, we built simple models to understand the equilibrium distribution found previously in numerical simulations. Using the method of maximizing the total entropy and the quadrupole mean field approximation, we determine the equilibrium distribution of axisymmetric two-component gravitating systems with two distinct masses, semi-major axes, and eccentricities. We also examine the limiting case when one of the components dominates over the total energy and angular momentum, approximately acting as a heat bath, which may represent the surrounding astrophysical environment such as the tidal perturbation from the galaxy, a massive perturber, a gas torus, or a nearby stellar system. Remarkably, the bodies above a critical mass in the subdominant component condense into a disk in a ubiquitous way. We identify the system parameters where the transition is smooth and where it is discontinuous. The latter cases exhibit a phase transition between an ordered disk-like state and a disordered, nearly spherical distribution both in the canonical and in the microcanonical ensembles for these long-range interacting systems. Next article. Chemical abundances in Seyfert galaxies x sulfur abundance estimates. For the first time, the sulfur abundance relative to hydrogen in the narrow line regions of a sample of Seyfert 2 nuclei has been derived via direct estimation of the electron temperature. Narrow emission line intensities from the SDSS Dr. 17 in the wavelength range 3000 less than lambda less than 9100, and from the literature for a sample of 45 nearby SET2 were considered. Our direct estimates indicate that SIT2s have similar temperatures in the gas region where most of the S ions are located in comparison with that of star-forming regions. However, SIT2s present higher temperature values in the region where most of the S ions are located relative to that of SFS. We derive the total sulfur abundance in the range of 6.2 less than 12 log less than 7.5, corresponding to 0.1 to 1.8 times the solar value. These sulfur abundance values are lower by 0.4 dex than those derived in SFS with similar metallicity, indicating a distinct chemical enrichment of the ism for these object classes. The SO values for our SIT2 sample present an abrupt decrease with increasing OH for the high metallicity regime 12 log greater than 8.7, what is not seen for the SFS. However, when our SIT2 estimates are combined with those from a large sample of star-forming regions, we did not find any dependence between SO and OH. Next article. A possible signature of the influence of tidal perturbations in dwarf galaxy scaling relations. Dwarf galaxies are excellent cosmological probes because their shallow potential wells make them very sensitive to the key processes that drive galaxy evolution, including baryonic feedback, tidal interactions, and ramp pressure stripping. However, some of the key parameters of dwarf galaxies, which help trace the effects of these processes, are still debated, including the relationship between their sizes and masses. We re-examine the Fornax cluster dwarf population from the point of view of isomass radius stellar mass relations using the Fornax Deep Survey Dwarf Galaxy Catalog with the centrally located 3.63 solar mass PC2 isodensity radius defining our fiducial relation. This relation is a powerful diagnostic tool for identifying dwarfs with unusual structure, as dwarf galaxies' remarkable monotonicity in light profile shapes, as a function of stellar mass, reduces the relation S-scatter tremendously. By examining how different dwarf properties correlate with distance from our fiducial relation, we find a significant population of structural outliers with comparatively lower central mass surface density and larger half-light radii residing in locally denser regions in the cluster, albeit with similar red colors. We propose that these faint, extended outliers likely formed through tidal disturbances, which make the dwarfs more diffuse, but with little mass loss. Comparing these outliers with ultra-diffuse galaxies, we find that the term UJ lacks discriminatory power. UJs in the Fornax cluster lie both on and off of ERSMAs defined at small radii, while ERSMA outliers with masses below 107.5 solar mass are excluded from the UJ classification due to their small effective radii. Next article. Stellar dynamical modeling counting conserved quantities. Knowing the conserved quantities that a galaxy's stellar orbits conform to is important in helping us understand the stellar distribution and structures within the galaxy. Isolating integrals of motion and resonances are particularly important, non-isolating integrals less so. We compare the behavior and results of two methods for counting the number of conserved quantities, one based on the correlation integral approach and the other a more recent method using machine learning. Both methods used stellar orbit trajectories in phase space as their only input, and we create such trajectories from theoretical spherical, axisymmetric, and triaxial model galaxies. The orbits have known isolating integrals and resonances. We find that neither method is fully effective in recovering the numbers of these quantities, nor in determining the number of non-isolating integrals. From a computer performance perspective, we find the correlation integral approach to be the faster. Determining the algebraic formulae of conserved quantities from the trajectories has not been possible due to the lack of an appropriate symbolic regression capability. Notwithstanding the shortcomings we have noted, it may be that the methods are usable as part of a trajectory analysis toolkit. Next article. Paradigmatic examples for testing models of optical light polarization by spheroidal dust. We present a general framework on how the polarization of radiation due to scattering, dichroic extinction, and birefringence of aligned spheroidal dust grains can be implemented and tested in 3D Monte Carlo radiative transfer codes. We derive a methodology for solving the radiative transfer equation governing the changes of the Stokes parameters in dust-enshrouded objects. We utilize the Euler matrix and the extinction, scattering, linear, and circular polarization cross-sections of spheroidal grains as well as electrons. An established NCRT code is used and its capabilities are extended to include the Stokes formalism. We compute changes in the polarization state of the light by scattering, dichroic extinction, and birefringence on spheroidal grains. The dependency of the optical depth and the albedo on the polarization is treated. The implementation of scattering by spheroidal grains both for random walk stacks as well as for directed scattering are described. The observable polarization of radiation of the objects is determined through an angle binning method for photon packages leaving the model space as well as through an inverse ray tracing routine for the generation of images. We present paradigmatic examples for which we derive analytical solutions of the optical light polarization by spheroidal dust particles. These tests are suited for benchmark verification of MAPOL and other such codes and allow to quantify the numerical precision reached. We demonstrate that MAPOL is in excellent agreement to within 0.1% of the Stokes parameters when compared to the analytical solutions. Next article. A study of carbon-rich post-act stars in the Milky Way to understand the production of carbonaceous dust from evolved stars. The goal of this study is to reconstruct the evolution and the dust formation processes during the final act phases of a sample of carbon-rich, post-act galactic stars, with particular attention to the determination of the past mass loss history. We study the excess of sources classified as single stars by means of dust formation modeling where dust grains form and grow in a static wind and expand from the surface of the star. The method is applied to various evolutionary stages of the final act phase of stars with different masses and metallicities. The detailed analysis of the set of the sources investigated, which included the derivation of the luminosities and the dust properties, is used to infer information on mass loss, efficiency of dust formation, and wind dynamics. We confirm previous results that most of the investigated sources descend from low-mass progenitors that reach the C-star stage. Metal-poor carbon stars are characterized by higher Ur excesses with respect to their more metal-rich counterparts of similar luminosity due to a higher surface carbon-to-oxygen excess. This work confirms previous conclusions that more luminous stars descending from higher mass progenitors are generally more opaque due to shorter evolutionary timescales that place the dust shell closer to the center. We also find that the mass loss rate at the tip of the act phase of metal-rich low-mass carbon stars is approximately 1 to 1.5x 10 to the power 5 m-SUNA, whereas in the metal-poor domain M4 to 5x 10 to the power 5 m-SUNA is required. These results indicate the need for an upwards revision of the theoretical mass loss rates of low-mass carbon stars in the available literature, which in turn require a revised determination of carbon dust yields by apt stars. Next article. Infrared polarization study of LINS 1340, a case of RNO8. This paper describes the polarization study of a LINS cloud, LDN 1340, alpha equal to 2H32 and delta equal to 7300, corresponding to galactic coordinates of letter 2 when 3 are equal to 130. 07b equal to 11. 6, with emphasis on the RNO8 area. The cloud has been observed using the 1.2 m telescope at NT Avo Infrared Observatory in the infrared wavelength band using the near-infrared camera spectrograph polarimeter instrument. The polarimetric observations were used to map the magnetic field geometry around the region. We combined our measurements with archival data from the two MASS and WISE surveys. The Gaia ETR 3 Dr. 3 data for the same region were used for distance, proper motion, and other astrophysical information. The analysis of the data reveals areas with ordered polarization vectors in the region of RNO8. The position angle measurements reveal polarization due to dichroic extinction, which is consistent with the galactic magnetic field. The magnetic field strength was calculated for the RNO8 region using the Chandrasekhar-Fermi method, and the value estimated is 42 μ. Next article. Abundance ratios of OCO and HCO as probes of the cosmic ray ionization rate in diffuse clouds. The cosmic ray ionization rate is one of the key parameters controlling the formation and destruction of various molecules in molecular clouds. However, the current most commonly used Crore tracers, such as H3O and H2O, are hard to detect and require the presence of background massive stars for absorption measurements. In this work, we propose an alternative method to infer the Crore in diffuse clouds using the abundance ratios of OCO and HCO. We have analyzed the responsive chemical abundances of CO, O, and HCO on various environmental parameters of the interstellar medium in diffuse clouds and found that their abundances are proportional to zeta-2. Our analytic expressions give an excellent calculation of the abundance of O for zeta-2 less than or equal to 1015 S1, which are potentially useful for modeling chemistry in hydrodynamical simulations. The abundances of O and HCO were found to monotonically decrease with increasing density, while the CO abundance shows the opposite trend. With high sensitivity absorption transitions of both CO and lines from ALMA, we have derived the H2 number densities toward 4 line of sights. Assuming a kinetic temperature of Tk equal to 50 K, we find a range of 102 cm3. By comparing the observed and model HCO ratios, we find that zeta-2 in our diffuse gas sample is in the range of 1.014.81.01016 to 0.5, 1.4, 2.4, 10, 15 as long. This is 2 times higher than the average value measured at higher extinction, supporting an attenuation of CRS as suggested by theoretical models. Next article. Target selection for the Dizzy Peculiar Velocity Survey. We describe the target selection and characteristics of the Dizzy Peculiar Velocity Survey, the largest survey of peculiar velocities using both the fundamental plane of galaxies and the Tully-Fisher relationship planned to date. We detail how we identify suitable early-type galaxies for the FP and suitable late-type galaxies for the TF relation using the photometric data provided by the Dizzy Legacy Imaging Survey. Dr. 9. Subsequently, we provide targets for 373,533 early-type galaxies and 118,637 late-type galaxies within the Dizzy 5-year footprint. We validate these photometric selections using existing morphological classifications. Furthermore, we demonstrate using survey validation data that Dizzy is able to measure the spectroscopic properties to sufficient precision to obtain PVS for our targets. Based on realistic Dizzy fiber assignment simulations and spectroscopic success rates, we predict the final Dizzy Peculiar Velocity Survey will obtain 133,000 FP-based and 53,000 TF-based PV measurements over an area of 14,000-2. Each of these components will be a factor of 4 or 5 larger than other recent samples. We forecast the ability of using these data to measure the clustering of galaxy positions and peculiar velocities from the combined Dizzy PV and bright galaxy surveys, which allows for cancellation of cosmic variance at low redshifts. With these forecasts, we anticipate a 4% statistical measurement on the growth rate of structure at Z less than 0.15. This is over 2 times better than achievable with redshifts from the BGS alone. The combined Dizzy PV and bright galaxy surveys will enable the most precise tests to date of the time and scale dependence of large-scale structure growth at Z less than 0.15. Next article. Anstorm 2 Roman 3 A nicer view of the variable X-ray obscure in MRK 817. EAG and Storm 2 collaboration targeted the Seyfert-1 galaxy MRK 817 for a year-long multi-wavelength coordinated reverberation mapping campaign including HST, SWIFT, XMM Newton, NICER, and ground-based observatories. Early observations with NICER and XMM revealed an X-ray state 10 times fainter than historical observations, consistent with the presence of a new dust-free, ionized obscure. The following analysis of NICER spectra attributes variability in the observed X-ray flux to changes in both the column density of the obscure by at least 1 order of magnitude and the intrinsic continuum brightness. While the X-ray flux generally remains in a faint state, there is one large flare during which MRK 817 returns to its historical mean flux. The obscuring gas is still present at lower column density during the flare, but it also becomes highly ionized, increasing its transparency. Correlation between the column density of the X-ray obscure and the strength of UV broad absorption lines suggests that the X-ray and UV continua are both affected by the same obscuration, consistent with a clumpy disk wind launched from the inner broad line region. Next article. Technical constraints on interstellar interferometry and spatially resolving the pulsar magnetosphere. Scintillations of pulsar radio signals caused by the interstellar medium can in principle be used for interstellar interferometry. Changes of the dynamic spectra as a function of pulsar longitude were in the past interpreted as having spatially resolved the pulsar magnetosphere. Guided by this prospect, we used VLBI observations of PSRB 123725 with the Arecibo and Green Bank radio telescopes at 324 MHz and analyzed such scintillations at separate longitudes of the pulse profile. We found that the French phase characteristics of the visibility function changed quasi-sinusoidally as a function of longitude. Also, the dynamic spectra from each of the telescopes shifted in frequency as a function of longitude. Similar effects were found for PSRB 113316. However, we show that these effects are not signatures of having resolved the pulsar magnetosphere. Instead, the changes can be related to the effect of low-level digitizing of the pulsar signal. After correcting for these effects, the frequency shifts largely disappeared. Residual effects may be partly due to feed polarization impurities. In view of our analysis, we think that observations with the intent of spatially resolving the pulsar magnetosphere need to be critically evaluated in terms of these constraints on interstellar interferometry.